Hi friends, we're going to discuss kinematics foundation topics. What do you mean by kinematics? Kinematics is a branch of physics. Is a branch of physics which deals with the motion without cause. So now a branch of physics deals with the motion without cause, in the sense, what is the cause here? Nothing but without any force here. Without any application of the force, we are describing about the motion of an object, right? That is we call as kinematics. Now, when you enter into the topic, into the kinematics, we have most important terms to understand that. What are the most important terms which you need to understand here? Is that first of all, rest, and the next is a motion. What do you mean by rest? What do you mean by motion? Rest in the sense what? For example, any object which is not changing its position, or place with respect to observer or time. For example, any object not changing its position or place with respect to time or observer, in the sense what? So, observer, who is the observer? I am the observer. You are all the students. You are staying at your respective places. You are not changing your position since 8:45. Okay. With respect to same the observer, I am the observer. I am observing you. I've been seeing last 1 hour. You are sitting at the same positions. You are not changing your place. So I can say that you are in rest position. With respect to time also, you are in the rest, right? Because at 8:45 you are at the same position. At 9:30 also you are in the same position. That means I can say that you people are all at rest. Let us say this table being rest from so many days in this classroom at this place, right? Now that is with respect to me. I am seeing this table here only. This table doesn't move here to there to here. It remains at the same position. So we can say that the table is at rest, right? So an object which is not changing its position or place with respect to observer or time is called as rest, or the object is said to be in rest position, right? Now, for example, an object lies on a table with respect to time. If I'll see from 8:45 a.m., right? This is with respect to time. In the same manner, a table at same place with respect to from last 1 week. This is also time with respect to last 1 week, or with respect to a person. With respect to person, I am the person. With respect to time, from last 1 week. Okay, it is at the same position. Now, coming to the motion. What do you mean by motion? Rest in the sense the object remains in the same position with respect to time or observer is called as rest. Coming to the motion. What do you mean by motion here? Any object is keep on changing its position or place. Any object, if it changes its place or position with respect to time or observer. For example, I'm as a teacher, I'm moving here and there with respect to observers. Now who are the observers? All the students are observers. With respect to you all, I'm in the motion. Whereas with respect to teacher, you all are at rest position. Okay? Now the same thing I can put up in different manner also with respect to time. Rajdhani Express is at 8:30 in the railway station. Now it has reached Secunderabad station from Hyderabad station too. Okay? From Hyderabad railway station to Secunderabad station it has reached at 9 o'clock. Okay? Means what you are telling? It was at 8:30. At 8:30 it was at Hyderabad station. Now it is at the Secunderabad station. Now the time is 9 am. Means 8:30 to 9. It has changed its position or place. Means it has traveled from Hyderabad to Secunderabad station. Okay. So that is the way with respect to time we will describe the motion. Right? Now, if you enter little more into the topic, we need to discuss about the motion. What type of motions are available for us? How many types of motions we are having in day-to-day life? In day-to-day life, we are noticing or we are finding around us, up or down, there are different type of motions we are noticing. What are the different types of motions we are noticing around? The different types of motions you can see here, that is, you can see types of motion. What are the types of motion? Now you can see here, first we have rectilinear motion, and we have oscillatory motion. What is that? Oscillatory motion. We have also rotatory motion. We have also rotatory motion. How many types of motions we are having? Rectilinear motion, oscillatory motion, rotatory motion. What are all these? Okay, if you go individually, if you are discussing with respect to one, first if you are seeing rectilinear motion, what do you mean by rectilinear motion? Linear motion. This is also be called as straight line motion. If any object is moving along the straight line, then the object is said to be in rectilinear motion. If any object moving along the straight line, then we can say it is in rectilinear motion, or the other names for this, linear motion, okay, one-dimensional motion, or one more, straight line motion also we call it as. Linear motion, one-dimensional motion, straight line motion, that's all called as rectilinear motion. Means an object which is moving along the straight line, we can take it as rectilinear motion. Of course, here there is a small adjustment or confusion. Rectilinear motion in the sense, along the road, along the straight line it is moving, but the object can move like this also in a form of curve. In a form of curve means on the same road, how the snake is moving. Okay, it is need not to be a straight line in the sense like this straight line. There itself along the one dimension, the object is moving, but in a curved path. Of course, this is we can say curvilinear motion. Curvilinear motion also. What is that? Curvilinear motion. Okay. For example, sir, road will not be straight. People will raise a doubt. Road will not be straight in the sense. Simple logic. This is a table. This is a straight line motion. Like this, object is moving along the straight line motion only. Like this, the object is moving. This is all moving in forward direction along the straight line. Okay. This object is moving along the forward direction, but in different manner. This we can say as curvilinear motion. Curvilinear motion. These are simple example. A car moving on a straight road, you can take up as example. A stone dropped from a certain height, you can take as an example as an exact rectilinear motion or straight line motion. Sometimes in this part, we can also explain curvilinear motion along the straight line, but the object is moving like in a form of curves. Now, coming to in such cases, since it is curvilinear motion, finally all the particles, for example, this is a duster. I am moving this duster along the straight line. In this, whatever all the particles, this foam and this wooden material, all are moving together only, right? Means all the particles are transferring from here to there along the straight line. So we name it as, another way is also called as translatory motion. Translatory motion. So total system of particle of an object is transferring. Let us say I will tell you here the another way that you can understand here. This is the one system. In this X, Y, Z, all the particles are available. Okay. The same system, under the same system, whatever the particles are there. If the system is moving here to here in the sense, the total system of the particles also moving like this here. Like this. All the particles are transferring from the initial position to final position, that is along the straight line. Okay, this is all we can call as, this phenomena we call as translatory motion. Translatory motion. Because rectilinear motion in the sense, of course, with respect to the name, we can say that we can define the motion of an object along the straight line. Okay, along the, finally it is moving along the one dimension from this position to that position, from this position to that position. But the total system of particle is transferring from here to there along the straight line. Okay, this is all we can discuss translatory motion. Nothing but is under the rectilinear motion. Okay, next, after the rectilinear motion or translatory motion, now I am going to oscillatory motion. Okay, so this is clear, I hope. Examples, you can say that a car is moving in the sense along the road in the sense. Road, if it is straight, okay, it will go straight. That is, we can call it as. Sometimes road also get crossed, but they will reach the destination is supposed to be along the straight line only. Such a way that it is we call as rectilinear motion, translatory motion, one dimensional motion, straight line motion also we can call. Right? Now, okay, next, rotatory motion if you go. What do you mean by rotatory motion? Now, people are having the doubt. What is the difference between curvilinear motion and rotatory motion? Curvilinear motion is curved, but along the straight line only is moving. But rotatory motion, how it is? This rotatory motion, when an object is moving about a fixed point, let us say an object is moving about a fixed point, is rotating. we call it as rotating. This object is moving like this about this fixed origin O. This fixed origin O. So we can call it as rotatory motion. An object moving about a fixed point around a circular path. Moving about a fixed point, remember, about a fixed point around a circular path is called as rotatory motion. Best example, Earth rotates around the sun, right? Earth rotates around its own axis also we can say, and around particular point also we can say as a rotation. Here two confusions are that this is the sun in the sense around the sun, Earth what it will do? It revolves around the sun and rotates about its own axis. Rotates about its own axis. For example, here two confusions are there. For example, this is a duster. The duster axis is this, is the center. If the duster is rotating about its own axis, then we call it as rotation. Okay. The duster which is moving about a fixed point. Here also fixed axis, fixed point. About a circular path, about a fixed point, if it is moving around a point in a circular path, if it is moving, this is we call as revolution. Okay, so we can say when an object rotates at a position about a fixed point, we call it as rotation. Means fan rotates. Let me tell you, fan rotates. This is a fixed axis which is not changing. So like this is about a fixed point is moving in a circular path around its circular path around the other object, we call it as revolution. About its own we call as rotation. See, this is we call rotation. If the same object is moving about a point, is called as revolution. Earth revolves around the sun, rotates about its own. Revolves around the sun. Sun is a fixed point there. About rotates around its own in the sense that itself is having the fixed point at its center. That's what we call rotation and revolution. Next, sun it's not changing position, it's rotating around itself. Okay. For example, if it is moving about a point, other point, not itself, other point, then we call as it is revolution around the circular path. Okay. Sometimes need not to be a circular path, but it revolves around a particular object. Usually rotation takes place in rigid body cases. Rigid body means which is not able to move, not able to transfer one place to another place. In such case, rotation takes place. We say it is as a rigid bodies. Since it is not transferred, it can able to rotate about its own axis. Okay. Then next, coming to the oscillatory motion. What do you mean by oscillatory motion? We know that simple, most of the people are having the oscillatory motion and vibratory motion. There is a small difference between them. Okay, first, what do you mean by oscillatory motion? If any object is moving from its equilibrium position to either sides, and if it returns back, then such type of motion we call as oscillatory motion. See, oscillatory motion in the sense, if any object moving to and fro motion, through the mean position, means to the same position, is called as, this is a mean position or equilibrium position we call. What is that? Equilibrium position we call, right? So if any object, let us say from here to here it has moved, okay? Now this much height it has raised, this much height it has raised, here also this much height it has raised. Means what I am trying to say, that any object from its original position to backward or forward, if it is moving and if it returns back to the same position, then we can call it as oscillatory motion. Okay, this is also called as vibratory motion. Vibratory motion. But there is a difference, small difference between a vibratory motion and oscillatory motion. When an object is oscillating, it just displacing with small angle, okay? So that's why this is we called as oscillatory motion. If it is not the small angle, sometimes the object will move like this much distance, like this also. This is random motion, it will do. Sometimes this type of motion we cannot call oscillatory motion, but we can call it as vibratory motion. Any object, let us say a scale, if you are holding and if you do pluck like this, if you are plucking it, then it vibrates much. Not with a small angle, it's large angle it will move. Okay, a blade, if you keep with the two rigid supports, if you pluck it, what happens? In that case, there is a vibration takes place. Okay, the difference between the vibration and oscillation. Oscillation takes place with the small angle displacement, very small angle, we can say less than 10 degrees, I can say. Okay, vibratory motion, okay, all the oscillatory motion can be considered as a vibratory motion, but all the vibratory motion cannot be considered under oscillatory motion. Okay, this is about the oscillatory motions. We can see oscillatory motion in the sense a wall clock which is having the pendulum, simple pendulum clock, I say, simple pendulum clock. Simple pendulum clock, how it rotates, it moves to and like this, to and from mean to the mean position. If this is 12 in the sense, again it comes back to the 12, comes to 12. With respect to that, we are having down oscillating pendulum also. Whenever it is moving to and fro with the small angle displacements, with respect to that, there are the seconds needle will move. There is a second needle will move. Due to the moving of seconds needle, what happens? Then the time period takes place. That gives the oscillatory motion. Is one of the best example. A branch of tree, a swing which is moving. Okay, these are all best examples of oscillatory motion. And water in a trough will move or will give small oscillatory motion. Okay, a guitar string. This all gives the oscillatory motions. Okay, these are the different types of motion. Then next, we will enter into next class parameters of, or we can say variables of motion, which describes or which explains about the motion, most important variables, not only for this lesson, for entire physics. These variables are important, that we are going to discuss. Thank you very much. Please subscribe it.